You know that feeling, that moment you just know something deep down.
Mm.
It's not like you thought through every single step. It's a flash, an instinct,
Hmm.
a gut feeling. Psychologists call that system one thinking fast, automatic.
Right.
But then there are those other times, right? The truly complex problems where you
Mhm.
have to slow down, you gather info, you weigh options, you break it down. Maybe grab paper, map it out.
Mm.
That's system two thinking, slow, deliberate, analytical.
Precisely. It's the fundamental difference between, say, recognizing a familiar face
Mm.
instantly in a crowd
Yeah.
and sitting down to solve a tricky, like, multi-step algebra problem. One's just effortless pattern recognition. The other takes conscious mental effort, structured analysis, logical steps.
And here's where it gets really interesting.
Yeah.
AI, well, AI is starting to develop this same kind of distinction. Inside itself,
Uh-huh.
it's moving beyond just those lightning-fast pattern-based responses, the AI equivalent of that gut feeling, towards something that looks a lot more like that slower, methodical,
Yeah.
system two-like thinking.
That's the core of what we're digging into today. Deliberative AI. Think of it as building slow-thinking capabilities into machines. It's a pretty significant evolution, really, designed to give AI systems the ability to reason, to plan, and crucially, to self-correct in much more sophisticated ways than we, typically see.
Okay. So we've pulled together a really substantial stack of material for this. Deep dive articles, cutting-edge research papers. We're tracing the history, digging into the tech, looking at where it's already popping up, and, yeah, tackling the big challenges still ahead.
Our mission for you today is basically to act as your guides through all this information. We're going to unpack these sources, pull out the most important nuggets, connect the dots, and give you the context you need to get up to speed quickly on this really complex but honestly critically important topic.
Yeah, hoping for some surprising facts, maybe a few aha moments,
Yeah.
and just a clear picture of what this shift in AI really means.
Exactly. Let's get into it.
Okay, let's unpack this. So kicking things off, how do we formally define deliberative AI? Like, what are the key characteristics that set it apart from the AI most of us interact with daily? Virtual assistants giving quick answers, image recognition, that sort of thing.
Well, at its heart, deliberative AI describes systems that don't just operate on a simple stimulus-response loop. They aren't just reacting to immediate input based on patterns they learned.
Okay.
Instead, they make decisions or generate outputs through explicit, reasoned processes. Before acting or answering, a deliberative system overtly considers, well, its internal state, its goals, the environment it's in, and it explores potential actions it could take.
So it's not just input received, output generated. There's like a thinking step in between.
Absolutely. There's an internal process that happens before the output is finalized. A key characteristic is having an explicit, often symbolic, internal model or representation of the world, or the problem space.
Huh.
You can picture it like the AI has an internal whiteboard or maybe a simulation environment.
Mm-hmm.
On this whiteboard, it can map out the current situation, lay out the problem, brainstorm potential solutions, maybe even simulate or predict the outcomes of different actions before it commits to doing anything in the real world.
That internal whiteboard analogy is really helpful. So
Mhm.
a non-deliberative system sees an obstacle, reacts by stopping or moving around it based on a simple rule.
Right. Reactive.
But a deliberative system sees the obstacle, understands it as a barrier on its internal map, considers its goal, like where it's ultimately trying to go,
Yeah.
and then plans the best sequence of steps, maybe even simulating a few paths on its whiteboard before moving.
Exactly. That planning and simulation capability is crucial. The core characteristics, from the sources, they really include having that explicit internal world model, actively using symbolic reasoning and planning, being strongly goal-oriented, pursuing objectives over sequences of actions, possessing predictive capabilities to simulate outcomes, and using hypothetical and temporal reasoning, thinking about what-if scenarios, considering past events or future steps.
That's a huge leap from purely reactive systems. Those are great for instant reflexes, but yeah, they struggle with foresight or strategy.
That distinction is fundamental, definitely. Reactive systems are incredibly fast, right? Which makes them excellent for immediate action, controlling a robot arm, grabbing something moving fast, or reacting to a sudden obstacle in a self-driving car.
Makes sense.
But because they lack that internal model and the planning ability, they're less adaptable to complex or new situations they weren't explicitly trained on. Deliberative systems, well, they might be slower, more computationally intensive initially while they do their internal thinking.
Right.
But they're designed specifically for those intricate tasks needing strategic thought, foresight, and complex planning over time.
Which brings us back perfectly to that System 1 versus System 2 idea, popularized by Daniel Kahneman.
Yeah, it's a really powerful lens to view this whole shift. Human System 1 is our fast, automatic, intuitive mode, recognizing a friend, understanding a simple sentence, reacting to a noise. It's efficient, but, prone to biases or errors in tricky situations. Totally. Human System 2 is our slow, effortful, analytical mode, solving that complex math problem, writing an essay, making a tough decision after weighing pros and cons. It's resource-intensive, but more reliable for complex stuff.
And a lot of the really impressive AI we see today, especially the big language models,
Yeah.
they often seem to operate more like System 1. Is that fair?
That's a fair characterization, yeah, in a functional sense. Models like LLMs are incredibly good at rapid pattern batching across huge data sets. They generate fluent text, find patterns, do tasks quickly based on statistics learned during training. They can sometimes mimic deep reasoning
Right, mimic.
by generating plausible outputs based on patterns, but it's often correlation without true causal or logical understanding like System 2 has. They generate the appearance of reasoning.
And deliberative AI is explicitly trying to build in those System 2-like capabilities.
Precisely. The goal is to embed these slower, deliberate analytical processes within the AI system itself during its operation. So it's not just about human engineers using their System 2 thinking to design the AI. It's about the AI system performing systematic problem solving, logical inference, applying abstract concepts, planning, during runtime to solve a user's query or task. It's the AI doing the slow thinking internally on the fly.
That operational distinction is really key, isn't it? The AI isn't just fetching a pre-computed answer or matching a pattern. It's actively processing, reasoning, constructing the answer.
Exactly. Now, it's important to remember, this is an analogy. We aren't trying to perfectly copy human thinking with all its biases, emotions, or limitations. The goal is to computationally capture the functional strengths of System 2 structured analysis, robust planning, logical consistency, systematic problem breakdown. Actually, artificial deliberation could potentially surpass human System 2 in some ways, just through sheer processing power and consistency.
Okay, so let's contrast this more starkly. What are the critical flaws of the current dominant, fast-thinking AI that deliberative AI is designed to fix? What are the big pain points we're hitting?
There are several really significant limitations you hit when you push current models beyond simple pattern recognition or info retrieval. First, the lack of true understanding or reasoning. They are correlation engines, brilliant at finding patterns, but they often don't have a deep conceptual grasp of the underlying info or causal links.
Which is exactly why we hear so much about hallucinations.
Hallucinations, exactly, because they operate on statistical probabilities and correlations from training data, not a grounded, verifiable logical process or an accurate internal world model.
Yeah.
They can confidently generate stuff that's factually wrong, nonsensical, even completely made up.
Wow.
They lack a reliable internal check against reality or logic.
And they seem to fall apart on complex multi-step tasks, too.
They do. Complex multi-step reasoning, keeping context straight over long interactions, making robust strategic plans, or solving problems that need breaking down into logical sub-problems. These are areas where current models often struggle. They can lose track of details, contradict themselves, or create plans that are just incoherent or inefficient.
It's like they can write beautiful sentences, but struggle putting together a complex argument or like a coherent plan.
That's a good way to put it. They also often lack the metacognitive ability to recognize when a problem is ill-defined, contradictory, or just unsolvable. They usually try to give an answer anyway, sometimes generating plausible-sounding but ultimately useless stuff.
Right.
And their knowledge is pretty much static after training. Adding new info often means expensive, time-consuming retraining of the whole huge model.
So the explicit purpose of developing deliberative AI is to directly address these weaknesses, to improve them.
Precisely. The goal is significant enhancement in actual reasoning capabilities, making the AI's decision-making more transparent and explainable, improving its ability to adapt robustly to new situations, and drastically reducing hallucinations while boosting factual accuracy by rooting outputs in verifiable step-by-step logic.
And why is this shift from fast to slow thinking so critical right now?
Because the limitations of current AI make them inherently unreliable for high-stakes domains, places where errors just can't be tolerated. Think about healthcare diagnostics, financial trading, legal analysis, complex engineering design.
Yeah, the consequences are huge.
A hallucination or a faulty plan there isn't just inconvenient, it can be catastrophic. Deliberative AI aims to provide the necessary trustworthiness and reliability for these demanding applications by enabling structured, transparent, verifiable processes. In those contexts, the benefits of slower, more accurate, more reliable decisions far outweigh the cost of reduced speed.
It sounds like we're trying to move AI into areas where dependability and trust are absolute deal breakers.
That's the core motivation, exactly. The clear goals are transform AI into a tool for profound problem-solving, complex decision support, moving beyond just quick responses, tackle hallucinations, lack of real reasoning, poor planning, brittleness head-on, enhance transparency and explainability, not just technically nice, but major goals for building trust and allowing audits. And underlying it all is this pursuit of a deeper understanding, moving beyond stats to grasping concepts, causal links, building consistent internal models aligned with reality. That's seen as essential for AI that's truly general, reliable, and ultimately trustworthy.
It almost sounds like some of these ideas, internal models, reasoning, they aren't entirely new. Like maybe the field is revisiting some earlier approaches.
You've absolutely hit on a crucial historical thread there. The concepts behind deliberative AI have deep roots, stretching way back to the beginnings of AI research. In the early days, the focus was heavily on automated reasoning and symbolic AI, often called JOF AI, good old-fashioned AI.
Right, JOF-AI.
Pioneer systems like the logic theory machine were built explicitly to do logical deduction, prove math theorems. Planning systems like STRIPs were designed to represent world states symbolically and find logical action sequences to reach a goal.
So before massive data sets and neural nets took over, AI was mostly seen as systems manipulating symbols and following logical rules.
Exactly. The main idea, the physical symbol system hypothesis, was that intelligence fundamentally came from representing knowledge with symbols and manipulating them using formal rules. Through the 80s and 90s, you saw sophisticated agent architectures designed for deliberation, like the Belief Desire Intention model, BDI.
BDI.
An AI agent built on BDI would have explicit internal representations of its beliefs about the world, desires or goals it wanted to achieve, and the ability to form intentions or plans, sequences of actions to fulfill those desires. IRMA was an early influential system implementing this.
But that symbolic approach, it eventually hit some major roadblocks, right?
Yeah.
Led to the AI winter for those kinds of systems.
It absolutely did. There were fundamental problems translating the messy, ambiguous, constantly changing real world into clean, discrete symbols. Incredibly hard. That was the transduction problem. And even if you got good symbols, reasoning with complex knowledge using pure logic could quickly become computationally intractable, just explode in complexity.
Yeah, I can see that.
These challenges seriously limited their practical use and scaling, paving the way for other approaches, reactive architectures focusing on immediate responses, and eventually connectionist models, neural networks, which excelled at learning directly from raw data without needing explicit symbolic rules.
And the huge success of neural networks led to the current era of LLMs, which then highlighted the very limitations we were just discussing.
Precisely. So the current move towards deliberative AI isn't just going back to pure JOF AI. It's a resurgence of interest, yes, but driven by recognizing the limits of purely reactive or connectionist systems like current LLMs and enabled by new tech capabilities. The strong trend now is towards hybridization.
Combining the strengths of both worlds, neural and symbolic.
That's the key insight from history, I think. The future of advanced AI likely lies in integrating the power of neural networks, learning from data, recognizing patterns, generating intuitive hypotheses with the rigor of symbolic engines representing explicit knowledge, applying formal logic, performing verifiable deduction.
Makes sense.
This hybrid approach seems the most promising path to bridge the System 1-like pattern recognition of neural nets with the System 2-like structured reasoning of symbolic systems. History teaches us there's no single silver bullet. Future AI needs a blend of these different computational mechanisms, much like our own complex cognition.
Okay, so if deliberative AI is about building these structured, reasoned processes into machines, how is that actually done? What are the technical approaches, the tools that enable this slow thinking?
Right. Enabling deliberation needs specific techniques, architectural designs. It goes beyond just scaling up existing models. These methods are all about structuring and enhancing the AI's reasoning process itself, often during the time it takes to generate a response.
Let's start with chain of thought prompting, SOT. A lot of listeners might have heard about this with LLMs already.
Yeah, so key prompting is a foundational technique mostly used with large language models. It involves instructing or prompting the LLM to basically articulate the intermediate steps of its reasoning process sequentially, asking it to show its work or think step by step before giving the final answer.
How does just asking it that enable deliberation?
Well, by forcing the model to generate and spell out intermediate steps, it structures the output to mimic linear reasoning. And this has been shown to significantly improve performance on tasks needing logical inference or multi-step calculation like arithmetic, complex, common sense questions.
Okay.
It also gives you a degree of transparency. You can see some representation of the steps the model claims it took.
But I've also heard that the chain of thought it generates, it might not be the actual way the model got the answer.
That's a crucial point, yeah. And it touches on a big challenge we'll get to later, the faithfulness dilemma. While COTI improves performance and gives you a visible output, the generated chain might not be a totally faithful picture of the model's true internal computation. It can sometimes be more like a plausible rationalization learned during training. The model generates a convincing step-by-step explanation to justify an answer it got through other, maybe less transparent means.
Ah, okay.
So while it was an important early step in using inference time computation for more structured outputs, its link to genuine internal reasoning is still debated. It was an emergent thing in larger models, showing you could get more structure without huge architectural changes.
Okay, so COTI is like writing out your steps in a line. What about tree of thoughts, TOTI? That sounds like it branches out more.
It does, exactly. Tree of thoughts is a more advanced approach. It moves beyond the linear sequence of COTI. It lets the AI explore multiple distinct reasoning paths, either simultaneously or sequentially. It structures the problem solving, like building a tree, where different branches are different lines of reasoning or possible intermediate thoughts.
How does that process actually work inside the AI?
It's iterative. At each step, instead of just generating one next step like COTI, the model generates multiple potential thoughts, different approaches, intermediate conclusions, next actions.
Right.
Then it uses some mechanism to evaluate these thoughts, assess which ones seem most promising or relevant. Based on that evaluation, it expands the promising thoughts into new branches and prunes or discards the less promising ones.
Prunes them, like cuts them off.
Yeah, it basically decides they're not worth pursuing. And finally, it uses search algorithms similar to ones in game-playing AI like chess or Go, maybe breadth-first search or depth-first search to navigate this tree, systematically exploring possibilities, backtracking if a path hits a dead end.
So it's actively brainstorming different ways to solve it, evaluating them, ditching bad ideas, kind of like how a human might explore options in their head.
Exactly. This systematic exploration lets it tackle much more complex problems that need looking ahead, considering multiple possibilities at once, or breaking the problem down in non-obvious ways. It seriously reduces the risk of committing to one bad path early on. And it enables a powerful form of self-correction by spotting unproductive branches and backtracking. It's shown much higher success rates on tasks needing complex exploration and planning, like creative problem-solving games.
What's the trade-off with something like TTT then? Seems more powerful.
The main one is computational expense. Exploring and evaluating multiple paths in a tree is significantly more resource-intensive than just generating one linear chain.
Makes sense.
It also needs more sophisticated prompting and control mechanisms to guide the generation, evaluation, and search effectively. But TT is a really crucial step in embedding explicit mechanisms for exploration, evaluation, and structured search right into the AI's reasoning process during inference.
We've talked prompting techniques. But what about how these models are trained? Can you train them to deliberate better?
Yes, absolutely. That brings in training methods like reinforcement learning with process reward, or RLPR. In standard reinforcement learning, an AI learns based on the final outcome. Did it win? Did it achieve the goal?
Right.
In RLPR, the reward signal isn't just based on the final outcome, but on the quality of the intermediate steps or the process taken to get to that outcome.
So you're rewarding the how, not just the what. That's interesting.
Precisely. The AI's actions here are its reasoning steps, and the environment is the problem state. A carefully designed reward function evaluates things like logical coherence, factual accuracy of intermediate steps, or sticking to specific procedures or safety rules. This evaluation often relies on feedback from another AI judge, or even humans.
I've heard companies like OpenAI and Anthropic talk about deliberative alignment. Is that an example of this RLPR?
It is, yeah. Deliberative alignment is a strategy using RLPR to train models to follow complex safety specs or ethical guidelines by actively reasoning through them and adhering to those steps. The reward is for the process of deliberating on and following the protocols, not just the end result.
What are the benefits of training at that?
It lets you incentivize the AI to adopt more reliable, robust, or safe reasoning pathways, especially when the final outcome is hard to verify automatically, but the steps can be judged. It can also help mitigate things like reward hacking.
Reward hacking.
Yeah, where an AI finds unintended, maybe unsafe shortcuts to get the final reward without actually solving the problem right. If the process is rewarded correctly, you can potentially avoid that. The challenge with RLPR, though, is designing effective process reward functions. It's often really difficult, needs deep understanding of good or safe reasoning in a complex area. And like Toti, there's a risk the model might learn to simulate good reasoning steps just to get the reward without truly understanding why they're good, another form of unfaithful reasoning. But RLPR is vital for instilling desired reasoning patterns when the process really matters.
Okay, so we have techniques within LLMs, training methods.
Hmm.
What about integrating more traditional AI approaches, like those search algorithms from game AI?
That's where integrating classic AI search and planning algorithms with modern neural nets comes in. Monte Carlo tree search, MCTS, is a prime example famously used in AlphaGo. MCTS is an intelligent search algorithm. It builds a tree representing possible future states or actions, balancing exploring new possibilities with exploiting paths that have looked promising before.
How does MCTS help with deliberation?
It provides a formal, structured framework for systematically exploring huge, complex solution spaces. It lets the AI build coherent plans by considering action sequences and evaluating their likely success. Modern systems integrate neural networks to make MCTS way more efficient.
How so?
Instead of random simulations or simple heuristics, the neural net acts as a powerful guide. It predicts the value of different states or suggests the most promising actions to explore, dramatically pruning the search space.
Alpha geometry, which we mentioned solving math problems.
Right.
Use this kind of thing, right?
Exactly. Alpha geometry used a combination. A language model part, acting a bit like intuition, suggested potentially useful geometric constructions. This then guided the search of a symbolic deduction engine doing rigorous proofs. It's a perfect example of a neural network guiding structured search within a deliberation process. MCTS handles vast search spaces, offers principled exploration, but the computational cost is still significant due to simulations and the memory needed for the search tree. Balancing exploration versus exploitation is also tricky to tune.
So we have techniques making LLMs show steps, others exploring paths, training methods, rewarding process, search algorithms, navigating possibilities. Is the ultimate goal maybe to combine different types of AI entirely, like neural and symbolic?
Yes, that's a really significant trend. Hybrid neural-symbolic models. This approach aims to get the best of both worlds by combining the strengths of neural networks and symbolic AI. Think of the neural net as the artist, great at pattern recognition, generating creative hypotheses, handling noisy, unstructured data.
Okay.
And the symbolic AI as the logician, excellent at applying explicit rules, doing logical deduction, maintaining consistency, providing structure.
And they actually work together in these models.
They do. In a hybrid system, the neural parts might handle initial perception, extract features from raw data, or generate initial hypotheses. These then get passed to symbolic components, which apply explicit knowledge, constraints, logical rules, or formal reasoning frameworks to guide, refine, or verify the neural outputs.
So it directly bridges that gap between System 1 pattern recognition and System 2 logical rigor.
Pretty much, yeah, leveraging the strengths of both.
And alpha geometry is the poster child for this in action.
Absolutely. Its success in complex geometry really shows the power of this hybridization. The neural part suggested ideas, the symbolic engine proved or disproved them rigorously. That allowed a level of performance on mathematical reasoning that purely neural or purely symbolic systems struggled with. The advantages are enhanced explainability because the symbolic parts give you explicit reasoning steps.
That's huge.
Improved robustness and generalization by combining learned patterns with explicit rules. And they're particularly good for tasks needing both unstructured input processing and logical reasoning.
What are the downsides or challenges here?
Well, increased model complexity, harder to design, train, maintain. Integrating fundamentally different paradigms isn't trivial. Symbolic components can require significant effort to encode knowledge, which can be laborious and brittle if the knowledge isn't quite right. And they can face scalability issues, potentially higher latency compared to pure neural systems due to the multi-step processing. But despite these challenges, hybrid models are increasingly seen as a cornerstone for building more advanced, trustworthy, deliberative AI. Looking at all these techniques together, QT, 2T, RLPR, MCTS with NNs, full hybrids,
Yeah.
the collective picture shows a clear movement. It's a shift away from generating single-pass direct answers.
Right.
Instead, it's towards building computational mechanisms that actively support iterative refinement, exploring alternatives, structured search, self-correction during the process of getting to a solution. These techniques are the core methods letting an AI genuinely think through problems computationally.
So all these techniques mean more computation happening after training. When you actually ask it something, how is that managed? Is it just slower?
That's what we call inference time computation. It's all the computational effort spent after training when the model is actually being used on new input. Unlike simpler models needing maybe one quick pass through the network, deliberative techniques inherently require more computation during this inference phase.
Because it's doing all that internal simulation, searching, step-by-step processing we talked about.
Exactly. COT generates sequences, 2T generates, evaluates, searches trees, MCTS runs simulations. All this happens during inference. This extra compute is where the thinking happens in practice.
Are there specific strategies to handle this, make it efficient?
Yes, definitely. For efficiency and quality, simple strategies include best-of-n sampling, generate multiple possible answers or reasoning paths using COT or 2T, then pick the best one using some evaluation criteria, maybe another AI judge or human feedback. More sophisticated methods involve adaptive sampling. The AI system itself might predict if generating more steps or exploring deeper is likely to improve the result and dynamically allocate compute accordingly. Early pruning in tree searches also helps cut off unpromising paths quickly.
So there's a direct trade-off. Better performance versus more time and cost.
That's the fundamental trade-off at inference, yes. More inference time compute almost always leads to better performance on complex reasoning tasks, higher accuracy, more robust answers, but it also significantly increases latency and computational cost.
Right.
A major research area is making this process more efficient, getting the most reasoning quality for the least compute. Adaptive methods, for instance, have shown they can get most of the performance gains of generating tons of samples by using only a fraction of that compute on average. Inference time compute is the practical engine of this slow thinking.
And this idea of allocating more time or compute for thinking, that's led to industry folks talking about things like a reasoning budget.
Yes, exactly. This concept directly makes that trade-off operational. It's the idea that an AI system can dynamically allocate more computational resources, time, internal steps, token generation specifically for complex problems, or when explicitly asked to think harder.
So I could ask the AI a question and then say, okay, spend more time on this one.
Precisely. Companies like Anthropic offer something like an extended thinking mode for their Claude 3.7 Sonnet model. It's the same underlying model, but when you enable this mode or set a higher thinking budget, it spends significantly more serial computation time breaking down the problem, planning, exploring different approaches before giving the final answer. They call it serial test time compute, and developers can literally set parameters for how much thinking budget to use.
Interesting.
OpenAI's O1 model also reportedly works like this, spending extra time thinking via a long internal chain of thought before presenting the output. Their analysis shows a strong correlation between answer accuracy on tough benchmarks and the logarithm of the computational effort the model spent thinking.
So basically, the harder it thinks, the more likely it is to be right.
Exactly. This explicit link between reasoning quality and increased compute points towards an emerging pay-for-thought principle in AI. Just like humans spend more effort on hard problems, these AI systems can adapt their processing depth. Users or systems integrating the AI might decide if the extra cost time, compute, is worth the expectation of a more thorough, accurate, well-reasoned answer. It makes the economics of deliberation explicit. It could lead to tiered AI services or models that autonomously decide to think harder based on the perceived complexity or importance of the task.
Okay, we've dug into what deliberative AI is, the tech powering its slow thinking. Now let's talk impact. What does this actually mean for the real world? Where are we seeing, or where could we see, this more thoughtful AI making a real difference?
This is where the potential really starts to shine. Deliberative AI is poised to unlock applications, solve problems that were just beyond the reach of purely fast-thinking AI because of a fundamental complexity barrier. It's about tackling tasks needing sophisticated understanding, strategic planning, reliable decision-making in dynamic situations.
Okay, give us some examples. Where is deliberation most critical? What fields?
Science and research are prime areas. I mean, these fields are inherently about complex problem solving, navigating vast knowledge, generating hypotheses, testing them rigorously.
How would deliberative AI actually contribute there? Like practically?
Think about accelerating discovery. In drug discovery, AI could reason about complex biological pathways, predict novel compound properties more accurately, or design optimal clinical trial strategies by simulating different scenarios.
Oh.
In material science, it could reason about atomic structures to design new materials from scratch. Climate modeling involves simulating incredibly complex, interacting systems over long timescales needs sophisticated reasoning and planning. And crucially, automated hypothesis generation. An AI that can reason about existing scientific literature, spot logical gaps, and propose novel, testable hypotheses that could dramatically speed up discovery across many disciplines.
Yeah.
OpenAI's O1 model, with its better reasoning, shows potential here. And AlphaGeometry's achievement in math not just solving Olympiad problems, but actually contributing a novel proof for one theorem that's a stunning example of AI contributing to new knowledge through structured reasoning. That's genuinely surprising and significant.
Wow, AI creating new mathematical knowledge. That is powerful.
Yeah.
What about high-stakes fields like healthcare? Trust is absolutely paramount there.
Absolutely crucial. In healthcare and medicine, errors are catastrophic. Decisions often involve synthesizing complex data under uncertainty. Deliberation is essential for reliability.
So how would it be applied? Diagnostics.
Treatment.
For complex diagnostics, yeah. A deliberative AI could synthesize vast patient data symptoms, history, labs, imaging, genomics, reason about interactions, consider multiple conditions, weigh evidence, generate a differential diagnosis.
It could even estimate the uncertainty for different diagnoses, vital for clinical decisions. It could help with personalized treatment planning, reasoning about a patient's unique situation to tailor plans. And imagine AI sifting through and synthesizing the exploding body of medical research to give relevant, reasoned insights to doctors right when they need them.
Finance also seems like a place demanding careful, step-by-step analysis. Lots of complexity and risk.
It certainly is. Complex market dynamics, huge risk management, navigating intricate regulations, these demand sophisticated reasoning and planning.
What could deliberative AI do in finance, specifically?
It could power advanced fraud detection, reasoning about subtle interconnected patterns across vast transaction networks, complex market analysis and strategic investment planning, evaluating opportunities under uncertainty, managing portfolios by reasoning about future scenarios and risks. Regulatory compliance is another big one. Interpreting and applying complex, changing financial rules needs logical reasoning. And personalized financial advice reasoning about a client's full situation, goals, risk tolerance, potential life events to generate tailored long-term strategies.
What about a really structured field like software engineering? Very logical.
Exactly. Software engineering is inherently logical, involves complex, multi-step tasks where correctness and reliability are key. Deliberative AI can be invaluable.
How so? Beyond just generating code snippets.
Yeah, it could help design more complex, architecturally sound software components by reasoning about system requirements, interactions, diagnose and fix intricate bugs by reasoning about the code's logic, execution flow, potential failure points. Formal verification mathematically proving system correctness is a prime example.
Proving correctness.
Yeah. Systems like Sarthi, aiming to automate end-to-end verification, require AI to reason through verification plans, generate logical assertions, execute proofs, analyze counterexamples, ensure full coverage.
So AI that can logically prove complex software works as intended. That's a huge leap.
It is. It uses iterative workflows, deep reasoning to handle those previously manual, complex verification tasks.
And for systems interacting with the physical world. Robots, autonomous vehicles.
Deliberation is vital there for handling complex, unpredictable real-world environments and tasks needing foresight. Advanced navigation and planning need AI to build and maintain sophisticated internal world models, plan long action sequences in dynamic environments, reason about obstacles, potential future states.
Like planning a complex delivery route that adjusts dynamically for traffic, road closures, maybe even unpredictable pedestrians.
Exactly that. Or a manufacturing robot optimizing a sequence of precise movements for a complex assembly. Many advanced autonomous systems are moving towards hybrid control architectures.
Hybrid control.
Yeah, combining a fast reactive layer for immediate responses like swerving with a slower deliberative layer for higher level strategy like planning the overall route or optimizing the long-term task sequence. Across all these areas, science, medicine, finance, engineering, autonomous systems, the common thread is that deliberative AI is tackling problems that had a complexity barrier for older AI. These are sophisticated, multifaceted tasks needing human-level or better reasoning and planning. Their value lies precisely in solving these previously intractable problems.
It really does sound transformative.
Yeah.
Not just automating repetitive stuff, but augmenting or even automating complex cognitive functions.
It is. One of the most profound potentials is what's sometimes called super agency, where AI isn't just doing tasks for humans, but acts as a powerful cognitive partner, significantly amplifying human creativity, productivity, impact.
So freeing up human experts to focus on the really high-level strategic thinking and creativity, taking the cognitive load.
Precisely. By handling the complex analysis, evaluating options, generating plans, diagnosing issues, deliberative AI could free up experts in medicine, science, engineering, law to focus on unique human contributions. High-level strategy, innovation, complex judgments involving values or empathy, building relationships. It also potentially democratizes access to specialized knowledge by lowering the skill barriers to leverage expert-level analysis, and it facilitates much deeper human-AI collaboration. The AI proposes solutions, simulates scenarios, generates analyses based on its reasoning. Humans refine them, add constraints, incorporate values or context, and the AI refines its process, creates powerful feedback loops for complex decisions, especially under uncertainty.
And that potential for generating new knowledge, like alpha geometry did,
Yeah.
that changes the nature of discovery itself, doesn't it?
It absolutely does. AI that can reason robustly can become a genuine co-creator of new insights and knowledge, accelerating discovery in science, engineering, potentially even art and other creative fields by exploring complex hypothesis spaces much more thoroughly than humans could alone.
So the core transformation isn't just job replacement, maybe, but a fundamental shift in how knowledge work gets done, with AI as a sophisticated thought partner.
That's the most compelling vision, I think. Creating deep human-AI collaboration, where AI's deliberative capabilities extend and amplify our collective capacity to solve the world's toughest problems.
This potential sounds incredibly powerful, valuable, but we talked about inference costs. What does all this sophistication cost? Financially? Computationally?
That's a critical part of the picture, definitely. While the economic impact from productivity gains is projected to be massive, McKinsey estimates a long-term opportunity of like $4.4 trillion annually from corporate AI adoption. With advanced reasoning as a key driver getting there comes with significant costs.
Where are those costs most obvious right now?
Evaluating and training these advanced reasoning models is way more expensive than before. Because they generate so many more tokens during their step-by-step thinking at inference time, the compute cost per query shoots up dramatically. Evaluating OpenAI's O1 model across just 7 benchmarks reportedly cost nearly $2,800, generating over 8 times more tokens than its predecessor. A single evaluation run on just one benchmark for O1 could top $1,800.
Wow, just testing the model cost that much. What about training them in the first place?
Training costs for frontier models are skyrocketing, unprecedented rate. Reports say they've grown 2-3 times per year for the past 8 years. The biggest training runs are projected to cost over $1 billion by 2027.
$1 billion for one training run.
Projected, yeah. And the majority of that cost, like 47% to 67%, is purely the specialized hardware GPUs, TPUs needed for these massive computations. This creates a huge economic challenge. Companies see the long-term strategic value, sure, but the path to short-term ROI on these immense investments can be unclear. Very few companies feel their current AI deployment is mature enough to deliver substantial returns, even though they plan to invest more.
And does this high cost risk concentrating this power in the hands of just a few large, well-funded players?
That's a real concern, yes. The financial barrier to entry to train or even run these frontier models is high, which could lead to concentration. However, the rapid development of increasingly capable open-source models offers a counterpoint. Suggests access might broaden over time, maybe with a delay compared to the top proprietary models. What we're seeing is a clear reasoning premium emerging. Advanced reasoning is inherently more computationally and financially expensive than simpler AI tasks. Deliberative processes need more steps. deeper exploration, more compute per query or training cycle. This premium hits not just training, but inference costs, even the cost of validating the systems.
So you pay more for the deeper thought. The economics depend on whether the value of the complex problem solved outweighs that premium.
Exactly. The economic tension is balancing the strategic value from solving tough problems against algorithmic efficiency and compute cost. This will likely lead to tiered AI services offering deeper, costlier thought for premium tasks, while simpler, cheaper models handle basic queries. It also pushes research towards more compute-frugal deliberation methods, getting significant reasoning gains with less overhead, making advanced deliberation more accessible.
Okay, so the potential of deliberative AI is vast, but the costs are high. What are the other really significant hurdles and challenges we face in getting this slow-thinking AI into widespread use?
Beyond the computational expense, there are several fundamental technical and systemic obstacles. That high compute cost is coupled with significant energy consumption, raising environmental concerns too. Balancing enhanced capability with economic and environmental sustainability is a key challenge.
And speed is still potentially an issue, right?
Yeah.
Deliberation implies being slower, inherently.
Yes, latency is critical. Deliberative processes inherently take more time than rapid, single-pass responses. This increased response time can be impractical, even dangerous, for real-time applications, autonomous vehicles, high-frequency trading, even some human-AI interactions needing quick back and forth.
Right.
While there are mitigation strategies optimizing algorithms, faster hardware, edge deployment, they often involve trade-offs with the depth or complexity of the deliberation. The core challenge is developing efficient deliberation, systems that can think complexly but fast enough to be useful in dynamic settings. These systems also face broader known AI scalability challenges, ensuring data quality for training and evaluation, managing model drift over time, the shortage of skilled talent to build and maintain these complex systems, immature tooling, and the complexities of governance and compliance for such intricate AI.
It sounds like pushing that efficiency frontier you mentioned is really paramount then, getting more reasoning bang for the compute buck.
It absolutely is. More deliberation usually means better results, but at increasing costs. A major research thrust is optimizing this trade-off, maximizing reasoning quality for a given compute budget. Developing adaptive methods where the AI dynamically adjusts its deliberation level based on problem complexity or user needs is key to pushing that frontier.
Beyond the purely technical, are there inherent risks in the nature of deliberation itself when a machine does it?
Yes, there are systemic weaknesses that can pop up. One is the risk of analysis paralysis or getting stuck in reasoning loops. It's analogous to humans getting overwhelmed by options, overthinking to inaction, or going in circles without finding a solution.
Could an AI literally get stuck just overthinking?
Theoretically, yes. Faced with an overly complex or poorly defined problem, or given a huge, unstructured reasoning budget, a deliberative AI could potentially get caught exploring endless possibilities, reevaluating the same options, failing to move forward. Particularly risky in autonomous systems where timely decisions are vital. In automated formal verification, for example, having a human in the loop is one proposed way to detect and break such unproductive loops. Building robust internal mechanisms for prioritization, tracking progress, and pruning bad search paths is crucial.
And the opposite problem, applying costly deliberation to something simple, wasting resources.
Exactly. Incredibly inefficient for a complex deliberative AI to fire up its full reasoning for what's 2 plus 2 or identifying a cat. Just like humans use System 1 for easy stuff, AI needs mechanisms to assess complexity and dynamically choose the right level of thinking, seamlessly switching between fast, intuitive responses for simple things and slow, deliberate processes for hard ones.
Okay, this next challenge feels really big, fundamental to trusting these systems. How do you evaluate deliberative AI? It's not just about the final answer being right anymore, is it? The process matters.
This is a unique and arguably the most significant challenge right now. For these systems, the process are the reasoning steps, sound, logical, verifiable, reliable, is just as important as the final output. Did the AI get it right through genuine understanding and reasoning, or by luck, or some opaque, brittle internal path?
Are standard AI benchmarks like MMLU or ARC good enough to test this kind of thing?
Well, they test certain aspects of reasoning and knowledge, and models like OpenAI's O3 are showing impressive human-level scores on things like ARC AGI. But these benchmarks have limits. They can have biases, narrow scope, and critically, often only test the final answer, not the reasoning process.
Right.
Plus, there's the constant risk of data contamination models maybe being inadvertently trained on stuff similar to the test sets, inflating scores. But the most critical challenge here, and we hinted at it with Q, is the faithfulness dilemma. This is a huge concern. Does the AI's articulated chain of thought or visible reasoning process genuinely reflect its actual internal computation? Or is it just a learned rationalization? A plausible story generated after the fact to explain or justify an answer reached through a different, possibly opaque or even flawed internal process.
So the AI could potentially generate a convincing explanation for its decision, without that explanation being the actual reason. It could be faking alignment or faking reasoning.
That is precisely the worry. The AI might learn to generate a convincing step-by-step justification for an answer it got through pattern matching or something else, rather than truly using that reasoning process to get the answer. If the articulated reasoning isn't faithful, then apparent transparency is misleading. And worst case, it could become a tool for sophisticated deception, a harmful conclusion justified by a fabricated but plausible reasoning chain. Ensuring faithfulness is a critical, ethical, and technical imperative. New evaluation approaches are urgently needed. Frameworks like Adele are trying to evaluate AI based on underlying cognitive abilities, not just task performance, aiming to assess the AI's ability profile to predict performance and explain why it succeeded or failed, looking deeper than just the output. The key takeaway on evaluation is this. For deliberative AI, the process is fundamentally defining. Evaluation must evolve to look under the hood, assessing logical soundness, efficiency, robustness, and faithfulness of those intermediate steps and internal mechanisms, not just output correctness, requires a parallel evolution in evaluation science itself.
This really brings us into the ethical, even philosophical implications. Machines that can reason.
Yeah.
That raises some profound questions, doesn't it?
They absolutely do. Ethically, a major one is accountability. If a deliberative AI, operating autonomously, making complex reasoned decisions causes harm in healthcare or finance, who's responsible? The accountability gap gets wider as AI becomes more autonomous and its processes more complex, even if meant to be transparent. Transparency is linked, as we said. Making the reasoning auditable, comprehensible, is seen as crucial for accountability, trust. Initiatives like the NTIA report emphasize earned trust via audits, assessments. Projects like Anthropic's visible thought process for Claude try to make deliberation itself transparent. However, as we just discussed with faithfulness, the nuance is vital. If the AI can generate plausible but unfaithful reasoning, seeming transparency can mislead. Ensuring the faithfulness of the transparency is a fundamental ethical technical challenge. And enhanced reasoning power means greater potential for misuse. AI reasoning about complex systems or human psychology could enable highly sophisticated social manipulation or disinformation, harder to detect because it seems plausibly reasoned.
Scary thought.
In autonomous weapons, AI reasoning raises severe human rights concerns, lack of human judgment, empathy, and lethal decisions leading to calls for treaties. Biases in data or design could be perpetuated and even justified by the AI's reasoning, making them harder to challenge. Beyond misuse, there are broader societal concerns, exacerbating inequality, widening digital divides, new social exclusion if access isn't equitable, the influence on human thinking, interaction, societal structures. Needs proactive ethical frameworks, governance, like the UNESCO recommendation on AI ethics.
And finally, the really deep end, the philosophical frontier. Does building these deliberative capabilities get us closer to AGI, to genuine machine intelligence, maybe even consciousness?
Many researchers see robust deliberation, reasoning, planning, reflection as crucial stepping stones towards artificial general intelligence. Yeah. Recent achievements like OpenAI's O3 hitting human level on generalization benchmarks like ARC AGI are seen as progress indicators. Deliberative alignment is viewed as foundational for future AGI safety. Autonomous agents with deliberation are also paving the way. The fundamental question remains, though, is deliberation sufficient for AGI or just necessary, among other things? This also reignites those long-standing philosophical debates about defining machine thought and understanding. Can a machine truly think? Is machine intelligence the same as human? Could a machine with sophisticated deliberation have subjective awareness, consciousness?
Questions going back to the Turing test and its limitations. Searle's Chinese room.
Exactly. Turing focused on behavior. Searle argued symbol manipulation isn't understanding. Counter-arguments from computational theory of mind say mind is software, potentially runnable on different hardware. The question deliberative AI poses is, does a highly sophisticated, functional, deliberative process imply genuine thought or understanding? Or is it still a convincing simulation without subjective awareness or real semantic grounding? Does alpha geometry understand geometry, or is it running a highly sophisticated but ultimately non-conscious logical algorithm?
And if machines can reason at or beyond human levels, how does that change our view of ourselves, our intelligence, our unique place?
It absolutely forces a reevaluation. If artificial entities rival or surpass human reasoning, it challenges traditional human-centric views, suggests intelligence isn't exclusively biological, raises profound questions about human-machine collaboration, coexistence, defining human, when intelligent non-biological entities are increasingly capable. Most AI research operates under weak AI building systems that act intelligently for tasks, not aiming for strong AI or consciousness. But as functional deliberation gets more human-like in complexity, the line blurs, making these philosophical questions more pressing, less academic. We need caution, avoid overstating claims about consciousness based purely on functional deliberation.
So looking ahead then, what's the long-term vision for deliberative AI? What milestones might we expect, say, next 5–10 years?
Next 5–10 years, likely continued significant improvement in AI reasoning for complex domains, coding, math, science, expansion of AI agents with better integrated reasoning, memory, handling multimodal info, strong focus on meta-thinking AI reflecting on its own reasoning, more sophisticated hybrid architectures becoming common, and persistent work on scalability, consistency, explainability, computational efficiency. We might also see emergence of AI-enabled deliberation platforms for human collective decision-making, though building public trust after AI failures will be a hurdle. And human-AI collaboration will mature AI as a more capable partner and strategic foresight scenario simulation.
And that ultimate vision you mentioned, combining fast and slow thinking seamlessly, like humans do.
That's a very compelling long-term vision, yeah.
Yeah.
Unified AI systems seamlessly integrating and dynamically switching between rapid System 1 like intuition and slower System 2 like deliberation, mirroring human cognitive flexibility. Hybrid agent architectures are early steps. Dynamic allocation of computational effort based on task difficulty will be crucial for both power and efficiency. And here is a critical final point, tying capabilities and challenges together. As deliberative AI systems advance, get more powerful, like O3 improving on O1, robust safety and alignment techniques must evolve in parallel.
Absolutely crucial.
Increased capability inherently means greater potential for misuse or unintended negative consequences if the AI's goals and processes aren't aligned with human values. The deliberative process itself is a prime target for alignment efforts, rewarding safe, ethical, trustworthy reasoning paths, building in mechanisms to prevent faking alignment. Sustainable success in earning public trust, especially given skepticism towards AI in critical roles, requires balancing capability growth with unwavering commitment to safety, transparency, ethical operation. The goal isn't just a smarter tool, but a truly wise and trustworthy partner for humanity. #tag outro.
So we've taken quite a deep dive into this fascinating world of deliberative AI. We've looked at what it is, explored the tech chain and tree of thoughts, hybrids, reasoning budgets, examined its potential to revolutionize fields from science to healthcare, finance, engineering, and grappled with the significant technical, economic, ethical, and philosophical challenges.
Yeah, this shift from purely fast thinking to incorporating slow thinking capabilities.
Yeah.
It isn't just some incremental technical change. It fundamentally impacts what problems AI can solve for us, changes how we'll interact with these increasingly sophisticated systems, and raises really profound questions about the future of work, even our understanding of intelligence itself.
It really shows us that the path to more capable AI isn't just about speed or scale, but also about depth, reflection. Which leaves us with this thought to maybe ponder. As AI gains the ability to truly think things through, are we ensuring these machines use that power to develop verifiable, trustworthy reasoning that genuinely helps us tackle the world's most complex problems? Or will they primarily just learn to simulate understanding and rationalize outcomes, becoming even more sophisticated black boxes?
Yeah, the journey to deliberative AI underscores that true intelligence involves not just rapid response, but that capacity for deep analysis and thoughtful reflection. How will our own slow thinking adapt and evolve as we partner with machines that can deliberate faster, perhaps more thoroughly than ever before?
Keep these ideas in mind as you encounter these increasingly capable systems out there. Clearly, a lot more to explore in this incredibly important and rapidly developing area.